there's a couple of maps in this title slide. On the left is one showing the eastern parts of Washington and Oregon and the border with Idaho. And in blue is the extent of glacial ice around the peak of the latest part of the Ice Age, which was about 18,000 years ago. And shown in yellow are the areas that were inundated by cataclysmic flooding in that
Can't seem to get rid of it.
general time period. I think there's a lot of people that aren't on mute, so there's a lot of background noise that's coming in. On the right is a map of focused on Asia, and it shows a pattern of large-scale flooding that also occurred around the time of the last ice age. So these are two areas that I'll be talking about in terms of the worldwide mega flooding. Now, I think being that this is a group of the Ice Age floods people, you know about the mega flooding that occurred in the northwestern US associated with the peak of the last ice age. And so this is one depiction of this, showing in blue the extent of glacial ice at that time that was coming out of the Cordilleran area in British Columbia, coming over the border with Washington, covering the Puget Sound area where you all are located right now, but also extending into parts of eastern Washington, northern Idaho, and western Montana. So associated with that time period of ice was a lot of water coming off the ice sheets and comprising large lakes that were impounded by the ice. The biggest one was Glacial Lake Missoula, and then a somewhat smaller one in eastern Washington covering the area of Spokane called Glacial Lake Columbia. On this map in brown are the areas where the massive flooding associated with these lakes and possibly associated with subglacial water that was coming out from under the ice sheets, inundated drainage of the Columbia River, going down into Oregon and inundating the Willamette Valley and eventually out into the ocean. Now, J. Harlan Bretz was mentioned, and some of you, or maybe all of you, know the story of his research on this region, where he argued, and it was actually 50 years ago, in the seminal paper that he produced, published in Journal of Geology in 1953, where he suggested that a very large scale, indeed catastrophic flood had produced what he interpreted as unique landforms that one sees most well developed in the eastern part of Washington state. So among the features that he described were eroded areas of the dark basalt bedrock shown down in the lower left, an area called by the local people Scabland, because it looked like big wounds that had been cut into the skin of the earth. And there were also features like dry falls, which may be familiar to many of you, located in the eastern part of Washington, where massive amounts of water cascaded over 400-foot high cliffs that went into deep cut inner channels. In addition, there were deposits of the sediment that was carried by these massive floods. And up in the upper left is one near Wilson Creek in Washington. You can see that there's a road that cuts across this, and this feature is very large. There's buildings on it. And the sediments overlying the basalt bedrock were also scoured by this water into streamlined hills seen down in the lower right. Another indication of how immense these cataclysmic floods were is the sizes of the bedrock blocks that were moved by the floodwater. And this one is about it's about 40 feet in length. And you can see that there's a lot of smaller ones, but they're also quite large, maybe 5-6 meters across. So in order to do this, we're not talking about a normal river. We're talking about something incredibly energetic, much more powerful than a normal river. Oh, let's see. I am not advancing. Oh, there we go. Okay. Another feature that is indicating the character of the flow are these immense dune-like features. You can see these are really very large. This is a road that crosses this. And these are dunes, but if you're familiar with sand dunes, which you can see on the coasts of Washington and Oregon, these are not sand dunes. These are composed of gravel and boulders. Wind does not move gravel and boulders. These are gravel dunes that are created by the immense flow of water. So these features are as much as 40, 50 feet high, and they are spaced at a couple of 100 feet in spacing. So these are incredibly large. You've probably seen ripples that develop in streams entering the coastal beaches of Washington and Oregon. You may have seen them on stream bottoms, and you know that such features form in normal rivers. This was not a normal river that produced these features. This was a catastrophic flood. Now, there was mention in the introduction that there are many accounts from literature, from religious texts of immense flooding that has occurred in the past. This is, of course, a woodcut showing a depiction of the Noachian debacle, which is described in vivid terms in the Hebrew and Christian Bibles. It is of interest as a geologist to me that even the word geology, which came from a Latin written text, according to the Oxford English Dictionary, was coined in an article written in 1690 by a scholar who was attempting to describe the nature of the earth before the Noachian debacle. And this scholar pointed out something that has puzzled biblical scholars for some time, in that the Noachian debacle, if you read Genesis carefully, is described as having two completely incompatible causes. One cause is that the waters upwelled from the great deep. In other words, they emerged from inside the earth itself. And the other one is that it rained 40 days and 40 nights to produce the immense flood. Now, this is something beyond my geological discussion because it has a lot to do with biblical scholarship. But from what I understand from biblical scholarship is that this is an indication of two different authors relating the account that is given in Genesis about the nature of this debacle. And similar accounts were actually common in the world at that time, and especially the ancient Hebrews who were taken to Babylon. The Babylonians had an account of a worldwide flood that would undoubtedly have impressed the Hebrew people that were in bondage in Babylon at the time. So these kinds of accounts are all over the world. The almost mythical origin of the empire in Japan, in China, is associated with giant floods that occurred on the Yellow River. And a somewhat mythical originator of the sort of Chinese civilization and its empire, called Yu the Great, was achieved his status because of his ability to control the massive floods that had affected the whole civilization. Here is a Japanese woodcut showing a depiction of Yu fighting against a monstrous flood in the shape of a dragon. Scholars have attempted to look worldwide at peoples that go back thousands of years, some with written accounts, as in Genesis, but many with only oral traditions, where they describe what to them was a worldwide flood. This map just shows some of the locations where these kinds of stories have occurred. You will notice that there's actually quite a lot of these in the northwestern US. That may not be an accident. This is a sort of depiction of one of the sort of pre-Columbian native people groups, this one on the Olympic Peninsula, where their story involved a wise man who warned the people to get ready for this inundation. The people scrambled into their canoes with food and water, and they survived by roping into the tallest mountains on the Olympic Peninsula, and thereby survived this inundation, which to them had covered the whole world. So is there a question? Sorry, there's a lot of background noise. I don't, but as I said, I'm happy to. Okay. Okay. Well, this is kind of a background because scientifically, over the past several decades, we have come to realize that there were immense floods associated with the same time period I mentioned earlier, the end of the last ice age, period about, maybe between 20 and 14,000 years ago. Shown in red are a whole lot of areas that have been documented much in the same way as J. Harlan Bretz documented the massive floods that occurred in the northwestern US. And these have an association, which a geologist would recognize. They are all associated with giant ice sheets that covered North America, Eurasia, and parts of the southern part of South America. They occur around the margins of those ice sheets, and there are physical reasons why they would occur. Another aspect of this is that these now have a scientific term that's associated with them called a mega flood. And that refers to the quantity of water that flows out from these events. And the measure of that is 1,000,000 cubic meters per second. Now, just what that means is kind of difficult to imagine. It's a little like astronomical numbers. Just by comparison, the biggest floods of rivers like the Columbia or the Mississippi, which are the biggest rivers we have in North America. And I'm not talking about their normal flow. I'm talking about the biggest floods that have been observed by people in historic times. They are typically tens of thousands of cubic meters per second. So 1,000,000 cubic meters is, millions of cubic meters are 100 times that. And some of these floods are even more than that. This is a quantity of water that is moving at high velocity. So the mass of the water and the velocity at which it moves gives you the energy. So I'm talking about massive amounts of water and massive amounts of energy for these events. So looking more closely at North America, this is a map of North America depicted at a certain point in the last ice age. And you can see that in the northern part of North America, here's Alaska up here, is Greenland over here, Canada. There are two giant ice sheets, one called the Cordilleran, which is covering the northern part of the Rocky Mountains, extending into the southern part of Alaska. The biggest ice sheet is the Laurentide, which sort of centers on Hudson Bay, and it covers all of the central and eastern part of North America. It had a connection over to Greenland. All of Newfoundland is covered. Now, these ice sheets depress the surface of the Earth. It's a massive amount of ice. They're miles thick. And what that means is there is a low point that develops all around the edge of this ice. And because the ice is melting, this low point fills in with water. So you get giant lakes that are associated with the margins of the ice sheet. There also can be lakes where the ice blocks drainage, and you get a lake like Glacial Lake Missoula. So the floods emanated from these lakes and from the margins of the ice. And you see the numbers here refer to specific ones that have been studied in the last, mostly the last 30 years by various geologists. The pink area is areas that were impacted by some of the larger of these events. So the one over where you recognize the northwestern US, this is the flood that I mentioned at the beginning that was studied by J. Harlan Bretz. But the part of that that affected the land that I showed in an earlier slide is this tiny part. The bigger part, extending 2,000 kilometers across the floor of the Pacific Ocean. These are the sediments that came out of the massive erosion that was generated in those floods. And it covers areas of the low points at 20,000 feet deep, the abyssal plain of the Pacific Ocean, way out into the ocean. There were many floods that affected parts of the Mississippi River drainage that came out of the area where the Great Lakes is today and further west. These went down the Mississippi and out into the Gulf of Mexico. There was also a massive flood that developed about 8,000 years ago as this big ice sheet, the Laurentide, began to waste away. So much water was surrounding it that it lifted the ice. The ice is lower in density than the water. And a massive flood went out into the northern Atlantic. It's only part of it is shown in this diagram. So this is all from a review article I did about 10 years ago. We now know even more floods that occurred associated with that. Here's some more detail of the patterns of some of this flooding that was associated with these giant ice sheets. Here's these areas that in red are sort of channels. We would call them valleys, but so much water was filling them that they became the channels of mega floods. These areas were impacted by the mega flood. So the area in eastern Washington is shown over on the left. This long area feeding it is area created by what's called the Bonneville flood, which came out of a predecessor of the Great Salt Lake and flowed down the Snake River. Over in the center and eastern part of the North America, you had these drainages that were affected by massive floods that came down the Mississippi, the Illinois River, the Ohio River, also streams in the Canadian prairies. Shown in dark blue are massive lakes that developed as the ice sheet receded away. This sort of hatch pattern has been inferred to be a massive subglacial flood that affected mainly Alberta coming into the central and eastern parts of Montana. These massive floods associated with the last ice age would undoubtedly have affected people. There were people certainly in Asia at that time, and recent archaeological work suggests that there were people in the Americas as well. There's a lot of work going on in the geoarchaeology area of how the people migrated from Asia into the Americas. And one earlier theory, which had a lot of support, was that they came somewhat later in the period, between about 15,000 and 13,500 years ago, as the big ice sheets were retreating. But we now know that there were people in the Americas well before that. They must have come at the time of the massive ice coverage. So another theory, more current, is that the people migrated along the coast and that they survived by hunting sea mammals and living off coastal resources. And they migrated all the way down into South America, where there's evidence from quite a long time ago. Recent evidence in New Mexico, in the area of White Sands, has demonstrated people were in that area about 20,000 years ago. So all of this is work in progress, but I'm only pointing out that the implications of this massive flooding is something that is tied into a lot of current scientific questions. But so far, I've talked about the massive flooding that affected North America. This is a topographic rendition of Asia focused on, well, it also includes a part of Europe, focused on the part of modern Russia known as Siberia, which is the northern part. And these mountain ranges, which the high altitude areas are shown in white, that occur on the borders of Siberia with Russia, or Siberia with China, and various other republics that occur in Central Asia, like Kazakhstan and Uzbekistan, and subsidiary semi-autonomous areas that are part of the Russian Federation that I'm going to mention. These are parts of the world that don't get visited very much. There are also very large basins that are not in the high mountain areas, the West Siberian Plain, the basin of the Caspian Sea, the basin of the Black Sea. All of these areas were affected by massive floods. This has come to be recognized in recent decades. This is relatively new discovery. The ice sheets that occurred to the north covered not just the land areas that we see on the map that I showed you, but also parts of what is the Arctic Ocean. This is a polar view of the Arctic Ocean, and you can see the deepest water areas are shown in blue. But the edges of the continent actually extend far out underwater, covering much of what the Arctic Ocean basin is. And the reason these are areas of continent that have water over them is that when those big ice sheets melted, the sea level of the world went up more than 100 meters, more than 300 feet. And that water covered these shelf areas that had previously been land. And what was discovered a number of decades ago by some of the Russian scientists was that these shelf areas were covered by massive ice sheets, like the Laurentide ice sheet. So here's some detail of the northern part of Europe, Scandinavia, the Norway, Sweden, Finland, and parts of European Russia, where the boundary of the ice extends way out into what is now the ocean. In fact, there was only a little piece of area between Svalbard, a mountainous projection off the seafloor, and Greenland that was actually an inlet into the Arctic Ocean. It was otherwise surrounded by ice. And this scientist, who I actually had the fortune of knowing, Mikhail Groswald from the Russian Academy of Sciences, proposed back in the, I think he started in the 1960s, but also in the 1970s, that these big ice sheets were associated with large glacial lakes, not unlike what I talked about for North America. And these glacial lakes had spillways that connected them to what used to be an inland sea called the Aral Sea that has been somewhat destroyed by the overuse of the rivers that fed it. Also, the modern Caspian Sea, which during the Ice Age was a water body twice as big as what it is. And also the modern Black Sea, which we think of as an arm of the world ocean because it's currently saltwater. But during the last Ice Age, the Black Sea was freshwater. It was filled with glacial runoff water that pushed the saltwater out. And it was an inundated water body, which actually had people living around it in areas that have now been inundated, probably by massive flooding. So here's a detailed map of part of this Eurasian set of waterways. In white at the top is this giant ice sheet. It covered parts of Northern Europe. It covered the Scandinavian countries. The present-day Baltic Sea was just underneath this ice, covered parts of northern Russia. And as I talked about for North America, this was surrounded by giant lakes. This one called Lake Mansi. And there were connections that led to the Aral Sea, the Caspian Sea, the Black Sea, and out into the Mediterranean. In other words, this glacial meltwater got out down into the Mediterranean. Now, around the western margin of this, there was a pathway for this water. The ice went across from north Norway into the northern isles of Britain and Ireland. And it was blocked at the northern end. So there was one pathway for that water to escape. Here's another depiction of this sequence of features, sort of on a cartoon of the shape of the Eurasia and a little bit of Africa. In purple are shown these giant lakes. In yellow are the spillways that connected them that Grosswald described. In red are areas coming off of mountain glaciers that fed into those lakes. And some of these areas show the zones of water, fresh water, that was spilling out in this direction through the Strait of Gibraltar, and in this direction through what's called the English Channel. So here is a map showing the topography that underlies the ocean water of the English Channel. That topography was top secret until about 15 years ago. And the reason for that being top secret was that during the Cold War, the former Soviet Union had a massive number of submarines. And those needed to have access out into the world ocean. So they either had to go around the northern part of the British Isles, or they had to go through the Strait of Dover and the English Channel. Well, the English Channel has a deep inner channel within it that was wanting to keep secret, because it's far easier to find the submarines if they're going shallow. What was kept secret, though, is this topography on the English Channel. This is the high areas and low areas, the shape of the English Channel, and all these streamlined elements that were created in what's the English Channel by massive mega flooding. In other words, the separation of Europe from France was created by mega floods during actually an earlier part of the last ice age. Here's another depiction of the detailed pattern, which you see in gray, a set not like a normal river where you have a single channel, but a set of interconnected channels like the Channeled Scabland. In other words, this is just not a dead ringer, but a very similar morphology to the Channeled Scabland. J. Harlan Bratz, who I was fortunate to know when I was very young and doing my PhD dissertation, tried to assure his fellow geologists that his ideas, although they seemed catastrophic and not to them, not scientific, that they needn't worry about their views of long-acting, normal type river processes, because the Channeled Scabland was unique. Well, this is one of the few things J. Harlan Bratz was wrong about. In the past several decades, many scientists, including me, but many others, have found evidence of many, many catastrophic floods around the world. So we've talked about these ones in Central Asia. I will say a little bit about some of my own experience in that area. That's a long story about which I probably need to write a book. But the place we're going to talk about is this area in here, where there were massive floods coming out of these mountain ranges that occur between China, Kazakhstan, and Siberia and Mongolia. If you go to a map, here's a good geography question for you. Find where all those places come together. it's not a place a lot of people get to. And that is an area from which some of these massive floods were generated. Yeah. So here's a detailed topography, mountains shown in red, lowlands shown in blue, of a couple of these areas, both of which I visited. The first one I visited in the early 90s, before the fall of the Soviet Union. That was a long story on what that was like. It was interesting culturally, politically, and in many other ways. But that area is called the Altai. And it was a autonomous region called the Gorno-Altai, inhabited by Turkic people who were not Russian, and they're really more similar to Mongolian people. The other region shown in green here is called Tuva. And Tuva consists of some very large basins that had immense glacial lakes in them. So the initial trip I went to was at the invitation of this guy, a Russian geomorphologist named Alexei Rudoy. Rudoy was in many ways, a flawed individual, but he was also someone who was pushing an idea that was very unpopular among his fellow scientists. It was the idea that massive cataclysmic floods had produced landscapes in this part of Russia. And he didn't have a lot of ability to contact Western literature, but he found out about work that was being done going all the way back to J. Harlan Bretz and later myself and some others that seemed consistent with what he was seeing. So in going in the field there, the evidence was overwhelming, massive. The flooding, here you see a road that goes into this region of the Altai. The little dot down there is a bus at the bottom of the road. And the guy up here is looking at coarse gravel carried in suspension by the flooding that filled this entire valley. So just like in the Channeled Scablands, there were valleys that were present, and they were, in some cases, too small to even carry the quantity of water. So here's another example. This is a place called the Little Yellowmon River, and you see the road at the bottom, and this is a massive gravel bar that from the major river here, shown on the picture at the bottom, the Katun River, blocks the valley of the Little Yellowmon River. And this thing is many hundreds of feet high. It is composed of coarse gravel and boulders, not easily seen on the picture here. There are giant gravel dunes on the gravel bar. So here's one of the pieces of particles, sediment, that was moved by these massive floods. This is similar to what we see in the Scabland, that the energy levels, because of the water being very deep, flowing very fast, is capable of moving blocks of material that seem impossible. But nevertheless, if you calculate all the physics that is generated associated with these floods, then they have to have produced the amount of energy to do this. The other thing that occurs in this region are giant gravel dunes. Here is a field of gravel dunes in the Kurai Basin. And one of the later researchers to go in this area, Paul Carling from Britain, has done radar penetration studies into these gravel dunes, showing that their structure is a kind of strata called foreset bedding that is indicative of how these were placed by massive flood flows. So the other area that I was able to visit is called Tuva. Tuva was made famous by the eclectic physicist Richard Feynman, who wrote a whole book about his finding in his father's stamp collection stamps from this region, which is famous to geographers because it's the geographical center of Asia, the center of the whole continent. Tuvan people have a unique culture where they do what's called throat singing, unique instruments. So, and here it is in the green where it's located, just north of Mongolia. The Tuvan people are closely related to Mongolian people. And so here's a map of Siberia, Mongolia. Grosswald, who I mentioned before, had recognized that in the headwaters of one of the biggest rivers in the world, the Yenisei River, which is this big river here, it goes into Tuva, and there were ice-dammed lakes. And these ice-dammed lakes also produced huge gravel dunes. You see the down on the bottom here. So here is a color picture from Google Earth of these gravel dunes. You can see how big they are because that little red dot, that happens to be Alexei Rudoy, and he is on a gravel dune that is about 50 or 60 feet high, just like the ones in eastern Washington. And it's in this massive dune field. You can see this little right strip. That's a road. It's probably just a dirt track, but it shows the size of these things. Tuva is also very well known. These pictures have come off of the current Russian propaganda media, showing an individual who gets into the news. This is an attempt to show that this person is a sort of normal human being in the Russian sense, an outdoors person, fishing, hunting, doing quasi-normal things. And Tuva is one of the places he goes because it is a kind of idyllic, remote place, and one can look manly and heroic in that place. Here I am at a meeting in 1996, that's me on the left, with Mikhail Grosswald and Alexei Rudoy. Both of them now dead, rather sadly in the case of Rudoy, but probably his problems of alcoholism and other defects led to that. Grosswald, much older, but very creative individual. So here's another depiction. I think this one was sent out with the announcement of my talk, that shows these massive patterns of Northern Hemisphere mega flooding from a sort of a polar view, with the ice sheets shown in the light bluish color, the purple showing some of these massive lakes. This was all a dynamic system that was changing through time with different patterns of flooding. It's a really big problem. It's now being studied by a great many people, and many new facts about it will be coming out. Those floods, big as they are not the largest mega floods that have occurred. And these things occurred in earlier Earth history. One of the biggest ones that is well documented created the Strait of Gibraltar and massive effects in the areas between Sicily and North Africa. This affected the basin of what is now the Mediterranean Sea. It occurred about 5.3 million years ago. The reason that this flooding occurred was that the tectonic plate on which Africa is located, seen in the bottom of the picture here, collided with the plate on which Europe is located, and it created a range of mountains, not a very high one, that crossed between the southern part of Spain and what is now Morocco. The climate was such at that time that any water that was in the Mediterranean basin evaporated, and this is evidenced in huge salt deposits that occur within that basin. And it was actually a dry desert. But also in the time period when this happened, called the Miocene, the sea level rose and it spilled over the low divide that connected Africa and Spain. It eroded a massive flood channel that is now the Strait of Gibraltar. So here's a sort of cartoon of the initiation of this process. But in terms of flooding, this is fed by the entire world ocean. And it produced a massive cataract, much bigger than the Dry Falls cataract, which is evident in the bathymetry of the Strait of Gibraltar. So just to show the sizes of some of these things I've been talking about, this is a diagram I did for a paper about 20 years ago. And there is a scale here you have to kind of take into consideration. The vertical part of the scale is much less than the horizontal part. So these features are much wider than what is shown if you were dealing with it in exact dimensions. But to show them in their relative size, they're depicted here. So the ones down in the lower corner here, the Mississippi and the Amazon, these are the biggest rivers on the earth that we have today. The Amazon is the biggest. And it may have had a massive flooding, about 300,000 cubic meters per second. That's not a mega flood. And in fact, there have been no documented mega floods in relatively recent Earth history. The other things on this diagram are mega floods, and the lower ones occurred during the last ice age. This is a Missoula flood channel. This is one in the Altai. This is the Strait of Dover. This massive thing is the Strait of Gibraltar. The Strait of Gibraltar, much bigger than the ones that I talked about for the last ice age. Now, what are these things? These are the biggest known mega flood channels we know of in the universe. They would have to be the subject of another entire talk because they occur on the planet Mars. This is a topographic view of a portion of the northern part of Mars with high topography shown in red and low areas shown in blue. And this pattern, which is not unlike the dividing and recombining channels of the Channeled Scabland, this pattern over here, these are massive mega flood channels. They are hundreds of kilometers wide. They are kilometers deep. As shown in the past diagram, they are incredibly immense. They are probably associated with massive changes on the planet Mars. So this is my last slide because I don't really have time to talk about Mars. It's another whole probably set of talks. Mars today looks like this. Unlike the popular sort of views in the media, it is not red. Mars is, the reason it looks red is we're looking at Mars through the Earth's atmosphere, and that changes the spectral property of the light that comes in to meet our eyes. It looks reddish because Earth's atmosphere is in the way of us looking at it. Mars is this color, and Earth looked at from space the same way we look at Mars, but we don't look at Earth this way. We look at it from seeing it on the land. Earth looks like this. If you were an alien, let's say coming from Vulcan in Star Trek or something, and you're looking at these planets and you wanted to give them a name, it's obvious what you do. The planet on the right, you see a little bit of this brownish stuff called land, but you see lots of this bluish stuff and this white stuff. And if you could see down here, this other white stuff, this is ice. Here, go back to this. I pressed the wrong button. Okay. So this is ice in Antarctica. These are clouds. This is ocean. Obviously, this planet should be called water. This planet is this brown stuff. This should be called Earth. And both of these planets have had histories that involve massive flooding because Mars, in its ancient past, and I'm talking about more than 3 billion years ago, had lots of water. Like Earth, it was a water planet. One of the big mysteries about Mars is what happened to all that water because it had huge, massive floods in the past, shown in red here, and it had a northern plains ocean. Those floods were associated with the formation of the ocean, just as the massive floods that happened in Earth history were associated with changes in the Earth's climate. But again, that's another story. And like all science, it's always about the next story. And it's a process that never ends. But unfortunately, my talk has to end. And we've come to the end of that. If I haven't raised questions in your mind, then I probably haven't been very successful in conveying something that I've spent much of my life studying. So thank you for the opportunity to talk to you, and be happy to entertain any questions.
Well, thank you, Dr. Baker. And I was monitoring the chat and I saw one we missed a long time ago at the very beginning. It was a question about the boulders on the Ephrata Fan right around Monster Rock. And let's see if I can find it. But
You saw a picture of that.
Yeah, Michael was asking, I can't find the question now, but Michael was asking if those were ice rafted or water rafted.
We know of many ice rafted blocks that are throughout the Channeled Scabland region, and they have certain properties that lead them to be deposited in certain places. They tend to be on the margins of the Scabland channels and also in backwater areas because the ice is floating. So it's at the top of the water flow and it's tending to accumulate around the margins. Also, a block like the giant monster rock is extremely heavy and dense. So if that were to be floated by ice, the piece of ice to do that would have to be incredibly larger than that block. And that is not a likely circumstance. But the other part of it is that all those boulders in the Afraid of Fan form a line of boulders that's near the center of the fan. In other words, it's not on the margins. These boulders were actually, they're right in the center thread of the massive high velocity water coming out of the Soap Lake constriction would carry them. It's not a place where ice rafted material would accumulate. Besides, there are hundreds or thousands of boulders there. That's not how you find ice rafted material. You find the ice rafted material is occasional blocks, often with a lot of smaller material around them. These are called berg mounds, or you find isolated blocks of material in the region of the Quincy Basin, where you have ice rafted material. It's generally granites that were associated with the margin of the glacial ice, which was not coming into the basalt area. That material, that glacial ice was coming out of the Okanagan Highlands. So it's crystalline rocks. So the ice rafted erratics are mainly granodiorite, not basalt. The basalt is actually eroded out of outcrops, and it has to be transported by floodwater. That's what I've just said is a geological argument for what is likely in regard to that block. To imagine it being ice rafted would require very special circumstances that go contrary to what I'm saying. But nevertheless, it is not an absolute answer, as much of what we say in geology isn't absolute. It is an answer that is a combination of reasoning that seems to be the most productive way of thinking about it. And until something striking that would make one think differently about it comes along, it seems to be our best idea of how those big blocks were formed. The difficulty with it, of course, is the incredible amount of energy that's needed to move those big blocks. And I currently have at least one colleague of mine that's trying to figure out how that worked.
We've got another question from Glenn. The Missoula floods repeated upwards of 100 times. Did these other floods repeat, or were they one-time events?
Well, there were 100 events that were associated with outbursts from glacial Lake Missoula. And the evidence for those 100 events are fine-grained deposits. These are generally sands, silts, and fine gravels. Those deposits can be produced at the energy level associated with an artificial flume a meter or two deep. The energy levels of the catastrophic Missoula floods were incredibly larger than that. And the places at which we find evidence of that massive energy is not 100 different timeframes. No. Also, those deposits that are associated with those fine deposits like that occur in the basin of glacial Lake Missoula. They occur in the bottoms of channels. And those channels are occupied by massive gravel bars with huge boulders on them. And there are, at a place called 9 Mile, there are 40 sets of rhythmites and they are emplaced and younger than a massive gravel bar that is hundreds of feet thick. The flooding that created that gravel bar would whisk away those sands and silts instantly. So the floods, those 40 events that occurred after the massive gravel bar were minuscule. They were floods. They were floods bigger than the river there today, but they were far less big than the massive flooding that did most of the work in the outflow of Glacial Lake Missoula. So yes, there were 100 events. The question, that's not the interesting question. The question that's important is which ones were really big and which ones were tiny. And we are still working on that part of the problem.
Questions from the audience here? Yes, sir.
Brits wrote about and drew maps of a glacier that he thought moved south of Spokane. That's not really talked about now. Was Brett's just looking at the bathtub ring of Glacial Lake Columbia and mapping that out as a glacier? What was Brett seeing that he thought was a glacier? And did you ever see anything you thought was a glacier that traveled south of Spokane?
This question about the glaciation that covered the region of Spokane has been one that was going on for quite a long time. In fact, there's a whole series of sort of online discussion going on with Nick Zentner out of Central Washington University about, I think it's called Ice Age Floods A to Z, in which he's reliving some of the early papers by many geologists from the time of Bretz's work, which was the early 1900s, and even before, when they were looking for evidence of the large margins of the ice sheets. And the evidence, which is rather clear in the Puget Sound area, where you had the clear evidence of the ice coming to moraines that mark the margins, becomes very problematic when you get into Eastern Washington. The one place where you do have excellent moraines is on the Waterville Plateau at the head of Moses Coulee. And there is a very odd moraine called the Withrow moraine. It has a bunch of peculiar properties to it, but nevertheless, it is a clear glacial moraine. When you go to the east of there, it becomes very problematic. At the junction of the Spokane River and the Columbia River coming down from the north out of Canada, there are traceable moraines there that are associated with the last ice age. But when you get into the area of Spokane, there is no true morainal topography. There were early investigators from the late 1800s into the early 1900s who went up onto the plateau surfaces south of Spokane and at the heads of what's called the Telford Crab Creek channels and areas to the west of Spokane on the plateau. And there they found sediments that included materials from the Okanagan Highlands. These sediments included gravels, not really much in the way of massive boulders that could be definitely distinguished from the catastrophic flood deposits that cover those areas. And Bretz himself, who didn't study a lot of that, relied upon the earlier literature of people who thought they were identifying glacial deposits in those areas. I have seen some of these deposits, and there are alternative explanations for them that that seem cogent. That some of what was interpreted were actually massive flood deposits, because these move large boulders. There are ice rafted erratics that are, and there's also sources in the steptoes that will produce lithologies in the flood materials that that are found in these areas. There's also, on top of the basalt, a deeply weathered zone that developed during the Miocene climate that produces clays. And on top of those are some gravels that have the local name Excelsior gravels that have exotic lithologies in them. These are still undergoing study. They don't have something that screams out glaciation at you. And they are quite old. They, as I said, they're associated with the Columbia River basalts were in place 16 million years ago. And the Pelusa that overlies that is generally glacial in age, which is the last 2 million years. So we're talking about, more than 10 million years of time in between. And so one idea that has been thought about for these odd deposits is that they may be post Columbia River basalt deposits that are related to the time before the Columbia River entrenched above the plateau, and they're related to very unenergetic streams coming off the Okanagan Islands onto the basalts and producing those lithologies. Anyway, it's an open question and worth discussing, and you could get another whole lecture on that topic. But I think other people have other questions, probably.
Yeah, we had another in the audience.
Yes, I was, the smaller rocks in the Afraid Fan, I wondered if those were size sorted by the velocity of the water. And what makes me think that is I've seen a boulder field at the head of Crab Creek Coulee that seemed to me that it was size sorted.
Well, the Afraid Fan is a massive megaflood fan. It was first described in much detail by Bretz, particularly in his 1956 paper, based on his 1950s field work. The Bureau of Reclamation did extensive studies of the Afraid Fan because, as you well know from going to it, it's large parts of it are covered with center pivot irrigation structures. And it was very important to them to understand the grain sizes all over the Afraid Fan, because if you irrigate on certain kinds of materials, you'll get salt buildup in your soil zone, which will be very bad for agriculture. So it's very important to know the highly high infiltration capacities, which are proportional to grain sizes. But basically, in general, the Afraid Fan has a spectacular fallout of grain sizes from close to the head of the fan, where it is entered by channels like they come through Soap Lake and cross High Hill and Pinto Ridge and in through Crab Creek. Those were big influxes for massive high energy floodwater. So in those areas, close to those influx points, you're going to find very coarse material. It's going to vary to some because this material is probably coming out as a kind of jet flow with a high velocity center and lower velocity zones where sediments are dropping out. The way the catastrophic floods carry the sediment is not like a normal river. The Mississippi, it fills up with sediment, it's sediment load. It's called the Big Muddy River because the sediment is just carried from near the headwaters all the way to the ocean. Catastrophic floods don't work that way. Catastrophic floods carry big stuff, And that stuff is carried in suspension. It is carried up in suspension because the energy is so high. When the floodwater comes out into an open basin, or when it comes out into the ocean, you have threads of high velocity and zones of low velocity. Wherever that velocity drops, the turbulence drops, and the big stuff just drops right out. And finer stuff drops out. And so it is dropping off very fast. When I did my dissertation in the late 1960s, and I wrote it, and my paper on it came out 50 years ago, I plotted the fallout of the grain sizes. And it's not like a normal river where grain sizes fall off with distance along the river in a certain way called a semi-logarithmic function. It's a power function. It falls off really fast, and it's because of this energy effect. So the parts of the Ephrata fan that are further from the source, as you get down toward the Frenchman Hills or the Potholes Reservoir, that's all sand. That's the finest stuff that came out. But even much of that flushed through Drumheller channels and through Frenchman Coulee, through Potholes Coulee, Crater Draw. So much of that sediment was being flushed through, but the part of the sand got trapped. And before all the center pivot irrigation, there were beautiful dune fields that covered the southern part of the Quincy Basin. Okay, so like everything else, there's a story that goes with the Ephrata fan, and there's more work we can do on it. But the Ephrata fan is not unlike some other massive mega flood fans we see both on Earth and Mars. So it's not a unique thing. We have many other places where there's similar sorts of things on Mars. In fact, I'm having an argument with the people associated with the Perseverance lander mission. It's in the news quite a lot. It's studying a place called the Jezero Delta. And the Jezero Delta on Mars has huge boulders over its surface. So although the media called this thing a delta, clearly the upper part of this thing is a massive cataclysmic flood fan. The people on the mission team don't have much experience with mega flood studies, so I don't think they quite understand what I'm trying to tell them, but they'll come around because nature has the answers, not us.
I see a question from Thomas in the chat. Thomas asks, the Crab Creek Channel has a different orientation, more east to west than the other channels. Could this be from a pre-existing water channel prior to the Missoula floods?
That is correct. Crab Creek was a pre-flood valley, and it was a meandering valley, and it was invaded by massive floodwater, much of which came from the north of this east to west flowing valley, came through what's called the Telford Crab Creek Scabland, which were the pre-flood northern tributaries. So the flooding was coming off of where Glacial Lake Columbia was later, and it came into through tributaries like Wilson Creek and Kanawai Creek and some others into Crab Creek. But Crab Creek itself was an ancient sinuous valley that was invaded by the floodwater. In fact, so much floodwater came into Crab Creek Valley that it spilled out of the valley into adjacent valleys. And that spilling was across divides. Those divide crossings were massively eroded. Divide crossings are the most massively eroded things in the Channeled Scabland. So as most of you know, the Grand Coulee is the most massive eroded feature in the Scablands. It is a divide crossing. there was a little bit of pre-flood valley, but it was rather minuscule. And much of the Grand Coulee was created by a immensely high cataract that receded northward from near Coulee City all the way up to the valley of the Columbia River, where the head of the Grand Coulee is actually hanging hundreds of feet above the level of the Columbia River. That is the product of the massive retreat of that cataract up there. So Grand Coulee was created by a very different process than the flooding that created the effects you see in Upper Crab Creek Valley, which, as you rightly point out, was a pre-flood drainage.
Other questions from the audience? Art?
Yes, Dr. Baker, can you recommend one technical paper or a book that captures some of the worldwide ice melting and flooding that you described earlier in this presentation?
Especially one with lots of pictures.
Well, it's ongoing work. There is a technical book from about 10 years ago called Mega Flooding on Earth and Mars. The editors are Devin Burr, who was my PhD student, Paul Carling, who is a English sort of flood person that had sort of picked up on a lot of my work, and myself. We're the editors of that book. And that described a lot of the worldwide locations. A more recent volume edited by Carling and myself appeared in the journal Earth Science Reviews. I don't remember the exact title, but it had a whole series of articles on these massive floods. I did a review article a couple of years ago from which some of the images and the slides appeared. You could email me at baker@arizona.edu. I can send you a copy of that article. So like much ongoing science, there's a lot of stuff that is in current literature in very technical papers. Many of the people doing this don't have the time to be writing up summaries of what's going on, but there are some that come about. Undoubtedly, this is the stuff of which popular books could be done, and there probably will be people that will pick up on that topic. I'm interested in doing some book things myself, but as you can see, there's a lot of things I'm involved in, so it's a little difficult to decide what one would concentrate on. And I have a lot of current scientific work with many colleagues that's also in progress.
Well, Dr. Baker, we know you're extremely busy, and we certainly appreciate you taking the time to share your research with us and putting up with our rocky start. But I think in the end, it was definitely worth it for all of us. So thank you very much. Appreciate it. And if all of you would hit the reactions button, and in the audience here, we can get real applause.
Okay, well, thank you very much. I always enjoy talking about my favorite subject, which is really big floods.